Yes, students, welcome to the second video lecture. I hope all of you have understood the first lecture. I have not got any doubts from you, so I am under the impression that all of you have studied that perfectly and you are thorough with. Now, just a brief revision of definition of sets. Set is a collection of students' well-defined items, objects, or numbers. All of you know that. Well-defined means we can chart out each and every element of a set. Then, students, there are two methods to list a set. One is listing method and another is property method, students. So I think we have done the third question of listing method. Now we are switching over to the set builder form or the property method. Now, students, the specific characteristics of this question, you can write answer in multiple ways. Provided you are correct, then the answer is, you can say, generally expressed in a correct way and is considered as correct. So here it is not necessary, students, that your answer must match with the answer given at the back. Now check the first set. It is of elements 3, 6, 9 and 12. 3, 6, 9 and 12, students, are multiples of 3. So when I am writing this set in set builder form, the answer to the first question is set A is equal to x such that x is a multiple of 3. Less than 15, and definitely x belongs to n. X such that x is a multiple of 3 less than 15 and x belongs to n. So multiples of 3 less than 15, students, are 3, 6, 9 and 12. Now second set, 2, 4, 8, 16 and 32. 2, 4, 8, 16 and 32. Here you should observe the rhythm. You should observe the characteristics of elements, students. Whenever you are writing a set in set builder form or property method, you should observe the rhythm in the elements. The rhythm in the elements is 2 raised to 1 is 2, 2 square is 4, 2 cube is 8, 2 to the power 4 is 16, 2 to the power 5 is 32. So these are all powers of 2. So I can write set B as set of elements x such that x is equal to 2 raised to n is less than 6 and n belongs to n. So less than 6 natural number, students, are 1, 2, 3, 4, 5. 2 raised to 1 will give us 2, 2 square will give us 4, 2 cube will give us 8, 2 to the power 4 is 16 and 2 raised to 5 is 32. Then the next set is 5, 25, 125 and 625. 5, 25, 125 and 625, all these are powers of 5. Same as the second sum. C is equal to set of elements x such that x is equal to 5 raised to n is less than 5 and n belongs to. So 5 raised to 4 will give us, students, 625. Then 2, 4, 6, 8 and onwards, students. Here you have to mark that this is an infinite set. And 2, 4, 6, 8 onwards are even natural numbers. So I can write x such that x is an even natural number. So this has, students, no boundary. It can go up to infinity. So I am writing set D is equal to x such that x is an even natural number, students. So definitely this becomes an infinite set. So 2, 4, 6, 8, 10. The first even natural number, students, starts from 2. So 2, 4, 6, 8, 10 and onwards. Okay, students, the fifth question. 1, 4, 9, 16 up to 100. Now, students, observe the rhythm or observe the pattern in the elements. 1, then 4. 4 is 2 square. 9 is 3 square. And 100 is 10 square. So I can write x such that x is a square of natural number from 1 to 10. X such that x is a square of natural number from 1 to 10. So that much I think you can write on your own. Now students, the fifth question, list all the elements of the following sets. So the sets are again given in property method, students, and we have to list the elements. So let us start, students. Question number 5. A is equal to x such that x is an odd natural number. Okay students, question number 5 we are starting with. Sorry, question 6 I think. Oh sorry students, previous was question number 4. This is question number 5. Now students, a is equal to x such that x is an odd natural number. Okay students, a is equal to x such that x is an odd natural number. Students, odd natural number starts from 1, then 3, then 5, then 7 and onwards. So students, here I am writing 1, 3, 5, 7, 9 and onwards. Specifically students, this is an infinite set. Students, this set is an infinite set. It has no upper boundary. Then students, b is equal to set x such that x is an integer and minus 1 by 2 less than x less than 9 by 2. Integers students. Integers are positive, negative including 0. And minus 1 by 2 is minus 0.5 and 9 by 2 is 4.5. So how many integers are there between minus 0.5 and 4.5? The answer is 0, 1, 2, 3 and 4. So students, here 5 elements. The elements are 0, 1, 2, 3 and 4. Then set c is equal to x such that x is an integer and x square less than or equal to 4. Students, x is an integer and its square is less than or equal to 4. Cite out how many integers have square less than or equal to 4. Definitely minus 2 square is 4, minus 1 square is 1, 0 square is 0, 1 square is 1, 2 square is 4. So minus 2, minus 1, 0, 1 and 2. 5 elements. Minus 2, minus 1, 0, 1 and 2. Then students, fourth. D is equal to x such that x is the letter of the word loyal. L-O-Y-A-L. Students, L is an element, O-Y-A. Recall, L is repeated. Repeated elements we don't write again in set. For set students, these two results are universal. Remember it. No elements are repeated in a set and the order in which elements are listed is not important, students. Any element is written first and any element is written second or third or at the last. Then students, set E. E is equal to x such that x is the month of year not having 31 days. Now we have to list out the months which do not have 31 days, students. You can easily count. January has 31 days, then February. So question is question number 5. E. So February definitely, March has 31 days, then April, then May has 31 days, June, January, February, March, April, May, June, July and August both has 31 days, then September, then October has 31 days, then last is November. So this is very easy, students, you can easily cite out. Then the sixth question, set f is equal to x such that x is the consonants in the English alphabet which precedes k. Now let me write all the alphabets up to k. Now let us start listing. A is a vowel, so A is not an element. B is not a vowel. C is not a vowel. D is not a vowel. E is a vowel. F is not a vowel. G is not a vowel. H is not a vowel. I is a vowel. J is not a vowel. it is preceding k. So total students we have written 7 elements, which are students B, C, D, F, G, H and J. Okay students, now the next question is match each of the set on the left in the roster form with the same set on the right described in the set builder form. So left hand side is roster form, listing method, and right hand side is property method, set builder form. Students, we have to match the correct pairs. Okay students, question 6 of exercise 1.1. Students, question 6 of exercise 1.1, match A with B. Okay, in A, the first set is, you can say 1, 2, 3, 6. Set of elements 1, 2, 3, 6. The second set is set of elements 2, 3. The third set is MATH, MATHEICS. And students, the fourth set is 1, 3, 5, 7, 9. These are the 4 set students which are given in, you can say, listing method, or you can say roster form. Now 1, 2, 3 and 6 students. 1, 2, 3 and 6. All these are factors of 6. Yes or no? Of course 1, then 6 is divisible by 2, 6 is divisible by 3, and 6 is divisible by itself. So the correct option is X, such that X is a natural number and divisor of X, such that X is a natural number and it is divisor of 6. Clear students? So the correct option for this is C. I am not writing that entire set. Then 2 and 3. Students, 2 and 3 both are divisor of 6, but students, 2 and 3 both are prime numbers. Students, the first prime number in terms of natural numbers is 2, then 3, then 5, then 7, then 11 and onwards. So 2 and 3 both are prime divisors of 6. So the correct option for 2 is A. Then MATHEICS, definitely X, says that X is a letter of the word mathematics. So here D. Now definitely B remains. So B says that X is an odd natural number less than 10. Odd natural numbers less than 10 are 1, 3, 5, 7 and 9 students. So this is how we match the set students. This is very simple, very easy. Now students, after exercise 1.1, the next definition is the definition of null set. Null set is a set which is of specific importance, students, in set theory. Okay, you feel that it is an element, means it is a set which is having no element. That is true, but I am not talking only in terms of definition or symbol, students. Null set, when we write solution sets in chapter 5, linear inequalities, whenever it is a solution set, a null set may be under consideration. So definition of null set, students. Null set has 3 names: null set, empty set, or void set. Students, what are the synonyms of null set, empty set and void set? A set having no element is called null set. Now a common mistake made here, students, is this. Be very careful. Null set, students, is a set having no element, means it is an empty set. So null set is denoted by this symbol, empty braces, or phi. It is PHI, phi. It is not 5, it is phi. It is a Greek alphabet. But if you write like this, then this is not a null set. Be very careful. It is a singleton set whose element is phi. So students, what is the definition of null set? A set having no elements or an empty set is called a null set. So in null set we have no elements. Null set is denoted by empty braces or it is denoted by the symbol phi, P-H-I. Okay students, then the next concept after null set in our textbook is the concept of finite and infinite sets. This is also very important. Students, say I write a set A has elements A, B, C and D. The number of elements of set A is denoted by n of A, and that is 4. Now I suppose students you are aware with the words finite and infinite. Finite means countable and infinite means uncountable. So a set having finite number of elements is called finite set, and a set having infinite number of elements is called an infinite set. So a set which has countable number of elements, students, that set is called finite set, and a set which has infinite number of elements, uncountable number of elements, is called an infinite set. So this set which I have written of elements A, B, C, D is a finite set, students, because the number of elements in set A are 4. But if I say set of odd natural numbers, which is 1, 3, 5, 7, 9 and onwards, students, then this set is an infinite set. So be very careful. Students, number of elements of any set is denoted by n of A. If it is set A, B, then n of B, set C, then n of C. Number of elements of a set is also called, students, cardinal number. Remember this. It is a term which is very useful in JEE and WHCAT. Number of elements of a set, students, is called its cardinal number. Be very, very careful, students, about this word. It is a synonym to number of elements of a set. So now I suppose, students, the concept of finite and infinite sets are very clear to you. And now let us go for the sums and application of this definitions. Exercise 1.2, students, we start. Now students, we start exercise 1.2. Now all of you pay attention. Exercise 1.2. Which of the following are examples of null set? Students, here we have to only tell whether the given set is a null set or not. Means if it is having no element, it becomes null set, otherwise not. Now the first set, set of odd natural numbers divisible by 2. Students, set of odd natural numbers divisible by 2. Now odd natural number starts from 1, 1, 3, 5, 7, 9 and onwards. Now none of these numbers are divisible by 2. 1 is not divisible by 2, 3 is not divisible by 2. So this set is definitely, students, a null set. Clear? Here no explanation is required. You have to only understand based on the description of set. So this first set is a null set. Set of even prime numbers. Set of even prime numbers. Now students, and here we should understand that x belongs to n is the inbuilt condition. So for natural numbers, the first prime number is 2. Yes or no? For natural numbers, the first prime number is 2 and 2 is an even prime number. Correct? So this is a singleton set, students, and definitely this is not a null set. Then x says that x is a natural number, x less than 5 and x greater than 7. At a time, students, it is given that x less than 5 and x less than 7. Can we have a number which is less than 5 also and greater than 7? No. So this is a null set. Then fourth, y such that y is the point common to any two parallel lines. Y such that y is the point common to any two parallel lines. You know students, parallel lines are non-intersecting and intersecting lines are never parallel. So parallel lines will have no point in common. So students, definitely this is a null set. So 1, 3 and 4 students, these sets are null set, and second is not, it is a singleton set. Okay, then same students, with the same guidance, with the same you can say procedure, we go for the second sum. Which of the following sets are finite or infinite? You have to only name students based on countable elements or uncountable elements. Countable elements, the set becomes finite. Uncountable elements, the set becomes infinite. Okay, the sets of month of a year. Now whenever we consider the set of months of a year, it is countable. As per the English calendar, we have 12 months. So this becomes which set students? Finite. Then 1, 2, 3 up to infinity. Now 1, 2, 3, 4, this is set of natural numbers. And all of you know students, set of natural numbers is an infinite set. Then third, 1, 2, 3, 4 up to 100. 1, 2, 3, 4 up to 100, these are first 100 natural numbers and which are countable. So definitely this set is finite. The set of positive integers greater than 100. Set of positive integers greater than 100. So the immediate next integer after 100 is 101, 102, 103 up to infinity. So this set is an infinite set. Set of prime numbers less than 99. Again here we have to understand that this is natural number. So we can count prime numbers less than 99 students. So this is a finite set. So we have to be very careful students about the, you can say, definitions and concepts. Now students, again the third question is based on the same pattern students. The third question is also based on same pattern. State whether each of the following sets is infinite or finite students. Here also we have to only discuss whether these sets are finite or infinite. The set of lines which are parallel to x-axis. Students, this is very interesting. Sets of lines which are parallel to x-axis. Let me draw and explain here. This requires understanding. Now students, all of you are familiar with x-axis and y-axis. So this is x-axis which is a horizontal line, and say this is y-axis which is a vertical line, and their intersection is origin. So what we are given students, set of lines which are parallel to x-axis. I can draw like this one line, I can draw like this another line, here also, here also. So there can be infinite number of lines students which are parallel to x-axis. So this set is an infinite set. Remember students, x-axis is a horizontal line and y-axis is a vertical line. In your chapter of coordinate geometry, you will study this in detail. But let me specify at this moment, x-axis is a horizontal line and y-axis is a vertical line. So we can draw infinite lines parallel to x-axis. So the first set is infinite. Then set of letters in the English alphabet. Set of letters students. Set of letters in the English alphabet. Now definitely you have 26 alphabets. You can easily count. So this is which set? Finite. Then set of numbers which are multiple of 5. Now set of numbers which are multiple of 5, 5, 10, 15, 20, 25, it goes up to infinite. So this is an infinite set. Then fourth, set of animals living on the earth. Now this is a debatable topic. set of animals living on the earth. Now on the earth, say whatever animals are there, we can club them and count. So this is a finite set. Let it be in millions or billions, but still we can count. Suppose it is 1 billion, 1.5 billion, 1.3 billion students, we can count. So this is a finite set. Then set of circles passing through origin. This is also, students, a debatable topic. Set of circles which are passing through origin. Say I am drawing 1 or 2 circles here. Say this is a circle which is passing through origin. Say this is a circle which is passing through origin. This is a circle which is passing through origin. So there can be infinite circles of different radii which are passing through origin, students. So this is again which set? An infinite set, students. Now the next concept, students, is the concept of equal sets. Students, that definition I am not considering at present, but let us revise the 2 definitions and one more definition which is a new definition which will be studied afterwards or used. A set having one element, students, is called a singleton set. A set having one element is called a singleton set. Suppose I write set A is equal to set of element A. Set C is equal to set of element phi. So students, a set having one element is called a singleton set. So we restrict our concepts to this topic up to exercise 1.2, students, question number 3. So in nutshell, let us revise the definitions which we have done today. A set having no element is called null set. Null set is also called empty set or void set. Then students, a set having finite or countable number of elements is called finite set. A set having uncountable number of elements is called an infinite set. Number of elements of any set A is denoted by n of A. Say here n of A is 1. N of A is also called cardinal number of the set. Students, this terminology is very important for competitive exam. So remember this, students, number of elements of set A is called cardinal number of set A. Number of elements of set B is called cardinal number of B. In general, number of elements is also called cardinal number. Students, so here we conclude our concepts and lecture. I advise you to write exercise 1.1, the whole exercise once again, and exercise 1.2, students, you do the first 3 sums. I have not written the definition of null set and finite set and empty set. You can even refer once and write it. You can say in your fair book as well as rough book. Students, though no definitions are asked in exam, never take definitions and concepts lightly. In mathematics, concepts, theories and definitions are of prime importance, even though definitions are not asked in exam. So write this definition once, try to cite out your own examples, and students, if you have any doubt in any of the questions, in any of the sub part of a question, you are always most welcome to message me, call me and ask me the doubt. Thank you, students. We conclude the lecture.